I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on method of images for the course Electromagnetic Fields. So, one important characteristics of the dipole field is the infinite plane at zero potential that exists midway between the charges. So, this type of plane may be represented by a very thin conducting plane that is infinite in extent. The conductor is an equipotential surface at a potential V is equal to 0, and therefore electric field intensity is normal to the surface. So, we replace the dipole configuration with a single charge and the conducting plane as shown in the diagram. So, in the diagram, left side we have a equipotential surface, that is the surface having the same magnitude of potential but opposite charges. So, plus Q and minus Q. So, this type of equipotential surface can be replaced by a conducting plane with charge plus Q. And according to the method of images, the fields in the upper half of each figure is 0. Below the conducting plane, we might also substitute a single negative charge to obtain a dipole arrangement. We know a dipole is the configuration which is having same and equal magnitude but opposite charges at both sides, and obtain equivalent for the fields in the lower half of the region. A single charge above the perfect conducting plane, and we maintain the same fields above the plane by removing the plane and locating a negative charge at a symmetrical location below the plane. So, this charge is called the image of the original charge and is the negative of that value. So, any charge configuration above an infinite ground plane may be replaced by an arrangement composed of the given charge configuration. So, its image and no conducting plane. So, this is the diagram. We have a conducting plane with two charges, and both are equipotential and having the surface charge density rho L. And in the similar diagram, we have the conducting plane is replaced and the equipotential surface with two charges plus Q and minus Q, having the charge density on the upper side rho L and negative charge density minus rho L. So, now we are going to see the method of images with an example. So, as an example of the use of images, we find the surface charge density at a point P of 2, 5, 0 on the conducting plane Z is equal to 0. If there is a line charge of 30 nanocoulomb per meter located at x equal to 0 and z equal to 3 as shown in the diagram, we remove the plane and install an image, a line charge of the opposite charge minus 30 nanocoulomb per meter at x equal to 0 and z equal to minus 3. So, the field at P may now be obtained by the superposition of the known fields of the line charges, and the radial vector from the positive line charge to P is R is equal to 2a z, x minus 3a z, and R is equal to plus 2ax plus 3az. So, the individual fields are, so in the diagram left side we have a conducting plane at point P of 2, 3, 0 we have to find out the electric field. So, at 30 nanocoulomb at z equal to 3 we have a line charge. So, now in order to obtain the total field by the method of images, the same magnitude but opposite charge minus 30 nanocoulomb is located at z equal to minus 3, that is exactly opposite sign on the z axis, negative z axis. Now, to get the total field at point P, the superposition of the two fields is obtained. So, here E total field is given by rho L by 2 pi epsilon naught R plus So this is for positive charge. So we substitute 30 into 10 power minus 9 by 2 pi epsilon naught, epsilon naught root of 13. So, and this is multiplied by 2ax minus 3az by root 13. Root 13 is obtained by square root of the magnitude of each potential charges. 2 square plus 3 square, we get root of 13. And now E can be obtained by 30 into 10 power minus 9 by 2 pi epsilon naught root 13 multiplied by 2ax plus 3az by root 13. This is for E minus. And by adding these two results, that is E plus and E minus, we get the total field E is equal to minus 180 into 10 power minus 10 Az by 2 pi epsilon naught of 13. And here it is equal to substituting all the values and epsilon naught value, it is 8.854 into 10 power minus 12. We get final answer for total electric field is minus 249 Az. The unit is volt per meter. So now the field at point P for both the configuration, that is certainly satisfying to note that the field is normal to the conducting plane as it must be. So thus D is equal to epsilon naught of E is equal to minus 2.20 Az nanocoulomb per meter square. And since the directed method, the conducting plane rho x is negative and the value is minus 2.20 nanocoulomb per meter square at point P. So in this way, we can easily find out the total field at any given point by using the method of images. So according to the method of images, the equipotential surface is replaced by a conducting plane and the exact opposite charge is replaced at the opposite plane, and the superposition of two charges is obtained to get the total field. So this is about the concept of method of images, and the method of images is very helpful for finding the total field as in the case of antennas, for monopole antennas or any grounded antenna. By using method of images we can get the total electric field. So the references.